Quarter 2, so I'm going to kick this off. Thanks for coming to this session this afternoon, which is on leveraging the cloud. And what we're going to talk about today is kind of like an extension of the speech that we had this morning, first thing on cloud solutions. We're going to talk about ways in which you can bring hosted solutions into the functional and price range that I think the vast majority of companies out there are looking for, leveraging the best that the cloud has to offer. And here's the challenge. There's an excess of hosted solutions out there today. Some companies approach it by actually putting T1s into the customer prem, supplying quite a bit of on-prem equipment, and then they end up with prices of $50 to $90 per phone per month. That's the PPPM. And that, for a great many people, is just too much money. Then you've got the guys at the other end of the spectrum who wanted to install it yourself, roll the dice on QoS, and they'll give you prices in the order of $25 per phone per month. In the first case, it's too many dollars. In the second case, it's too much risk. If you take the cost of the typical on-prem PBX from a short-tail or VIA type supplier, amortize that over 5 years, you end up with a price of about $30 per phone per month. So we've got to do better than that if we're going to actually get people to migrate from current solutions to hosted solutions. And so that's what we're going to address in the presentation today. So the issue is we need to find out a way in which we can drive down cost while maintaining good call quality, high functionality, and above all, with any phone system, excellent reliability. And the plan of attack is to first of all take a look at the QoS problem, because you don't have the bucks to go out and install T1s and everybody is prem. It's just not viable. Most people say that the QoS problems are in the last mile. Most of the time, it's not true. It's elsewhere in the network. You've got to get the PBX density up if you want to get these prices down, and it also helps you from the standpoint of maintaining it, making it easier to maintain and back up your systems. And you've got to have something which is a great differentiator in terms of apps. Plain vanilla phone systems are a commodity product these days. And if you can see that very well, actually, but anyway, this is a chart. What we're going to talk about, first of all, is quality of service. We're going to keep the last mile constant, and we're going to measure packet jitter, packet loss, and all the usual things that we think about with quality of service to different locations in the country from the same customer prem. And I don't know if you can see this or not, but there's a green line there. And the chart shows packet jitter in the upstream and downstream direction. And then the blue line, which is this guy here, is the mean opinion score. Now, the mean opinion score you probably know, but for those who haven't come across it before, it's a way of assessing call quality, and a MULO codec has a theoretical maximum of about 4.3. It goes between 0 and 5. And by the time the MOS gets below about 3-ish, 2.9, 3-ish, the call is noticeably degraded. By the time it gets down to about 2, it's worse than cell phone quality, and it's almost unlistenable to. This particular customer, these are 3 of our data centers. One is in Albany, one is in Washington, D.C., and one is in Seattle. This particular customer is only 10 miles away from the Albany data center. And yet you can see here that the mean opinion score is in the dirt. Terrible. This actual customer was previously a customer of a major hosted provider at the $25 end of the spectrum, and calls were just awful, and they were blaming it on the ISP. You can see here, these are taken in 25-minute segments, so they're all the same time of day. You can see here in the next sector, when we go to the data center in Washington, D.C., all of a sudden, mean opinion score is above the green line. Last mile stayed the same, but the call quality suddenly improved. So it was nothing to do with the ISP. It was to do with the packet loss on the actual routers that were connecting his ISP and his location to our Albany data center servers. Even the call quality to the Seattle data center, which instead of being 10 miles away was 3,000 miles away, is better than the local guy. Here's another one. This guy is also in upstate New York, and again, the local data center is far worse than the data centers that are far removed. And then the final one shows a customer in North Manchester, Indiana, who's actually good to all three data centers. So we're yet to find we have a setup that looks like this. So what we do is we set up a large number of data centers, and then we run an app on the customer prem. And what that does is it scans from the customer prem to the various data centers that we have and measures call quality to each of the locations. And then that customer's PBX is cited in the data center, okay, which gives him the best quality of service. It's very similar to the way in which a cell phone goes out and hunts for a cell tower. Here we've got a customer who could be anywhere in the country, in fact, for that matter, could be anywhere in the world, and the app goes out, scans all the data centers we have, and then finds the one that's the best, and then that's where the guy's PBX is placed. And to this point in time, we're yet to find anybody, okay, I mean, I'm sure they're out there, but we're yet to find anybody where we can't find a data center that gives them satisfactory call quality. So now what we've got is the ability to leverage standard connections, which are improving all the time, minimum of cable, moving up to fiber connections and so on. Standard connections with good call quality takes a lot of the price out of the solution. The next thing you've got to do is if you're going to support lots and lots of data centers, you have to have a very high PBX density, because you can't have loads of servers for customers that range in size from half a dozen phones to hundreds of phones, each one with their own machine, even if it's a virtual machine. It's just too expensive. So what we did was we addressed this with the creation of a language, which is an XML-based language we call TSDL, and a compiler. And the system works like this. So all the various companies that are going to be located on a particular server have an XML file in a schema that's pertinent to what a customer wants to describe. They want to describe their users, their IVRs, yes, their phones, and so on and so forth. And all of these come together with another special file, which is called a core file, which describes how to access trunks and other common media for that particular server. Those files then go into a document processor, which is written in a language called XQuery. And what that does is it pushes all of those files together into a single XML file of a different schema, which can then be sent to a compiler, which then outputs a whole bunch of files to a server. And the servers, gateways, phones, Polycom phones, are ones that we like, and so on and so forth. So now we have a way in which we can actually fit commonly, I'd say about 2,000 phones on every server in the network. When the servers aren't anything special, they're kind of your average quad-core Xeon type thing. And you can chop those 2,000 phones up any way you like. You can have one company of 2,000, you could have 10 companies of 200, or 200 companies of 10. It doesn't make any difference. They all fit on there in the same way. And that's going to give us, let me just zoom back a little bit, a way now in which we can afford to have these servers distributed all around the country at very little cost, because we can pack in the PBXs. Any questions on this so far? No? Okay. The other thing that the compiler type approach has as a benefit is we have a way now of building in an application language. Asterisk already has kind of I wouldn't call it a high-level language, it has AEL, which you may or may not have used, to try and sort of make it easier to write apps there. But if you were to move it up even further and then have the compiler take on the responsibility of taking that language and pushing it down to the server, then you can put apps in. And you need some great apps to differentiate your service. This is one which, for example, allows calls to not only be recorded but annotated. So if I've got a call center and I want to sort of see how salespeople are performing, I can not only play the call from the browser, but I can also mark it at various points in time, write in a comment, and then when I click on the comment, it goes exactly to that point in the overall track and replays the dialogue from that point. So I can easily sort of go back to the agent and say, hey, here's where you could have done better. Click on the comment, plays the actual portion of the track, and away you go. And all of these apps now, which take a lot of engineering time, get to be leveraged across all of those companies that are sitting on each one of those servers. So it makes it possible to put a lot of effort into some of these things. Okay. So bottom line is this. If you come up with this kind of new way of approaching the QoS problem, where you go out there and you're scanning around a lot of data centers, just like a cell phone looks for a cell tower, you can indeed take the vast majority of locations and provide them with high-quality voice service without the cost of putting in T1s and other dedicated connections just for the phone function. If you do that, you're going to have to find a way in which you concentrate PBXs on servers. It's rather like the presentation that Martin gave us this morning. He says you've got to figure out how to grow wide and not up. So you've got to find out ways in which you can take these PBXs and move them over lots of servers, because this also has a great benefit from the standpoint of redundancy as well. If a server should go down, you can move it to another server in moments. You can also use the same approach to actually have backups existing in other locations which don't consume any processing power. So I can actually switch from a server that fails to a server that's active with your PBX configuration on it very quickly at very little cost. So that's another plus as well. The other thing is as well, we've found that the data centers and the virtual machines that you can get on them vary in quality enormously. I don't know whether it's kind of the cloud technology that they use or not, but the servers we've tried at Amazon, I'd call them very lumpy. So if you were to run benchmarks on them, you would find that there was a huge variation in the time that it takes to run these benchmarks on their servers. It doesn't matter if you're running a website or an email service or something that's non-real time. But if it's running real-time functionality like a PBX, it's going to screw you up. And that there are other providers out there who use different cloud technology who give you very smooth performance. So just be wary of kind of where you might cite these things. The next point is the apps. That's really what it's all about today. Just like with the iPhone at one end of the spectrum, when you come to the PBXs at the other end, you have to have some way in which your service is going to differentiate itself so your customer is going to save money or make more money, even better, over your solution as to buying one of the more standard solutions. And then finally, the system that I'm talking about today has actually been in operation There are thousands of phones out there that actually now use this technology. It's been out there for a couple of years, and the results are good. So we have a large database, okay, to call upon here to say that, yes, this approach really does deliver the performance that we talked about this afternoon. Any questions?